Okay, we are now ready for section 8.2b, which will be more on the formulas and the real-world examples associated with that section. I think I said the last video was 8.2b, but that was actually 8.2a, and I'm not remaking it again. Your math instructor's losing her sanity, but doing the best she can. All right, I'm also noticing when I watch my videos that it's not real clear what's on the screen, but if you print out your notes that I send you, then you can follow along with your own notes and jot things down with your notes as you watch my videos. And I know some of you may not have printers at home, but maybe a friend could do that for you. So look to your friends, send them my notes, ask them if they can print them out for you, and then just drop them off at your door. I know we're all trying to keep 6 feet distances, but do the best you can. All right, so we continue on now. So here's some formulas that you need. The sum of the interior angles of a polygon. That will be n minus 2 times 180, where n is the size of the polygon. So with triangle, 3 minus 2 times 180 is equal to 180 degrees. And for a quadrilateral, it would be 4 minus 2 times 180, which would be 360 degrees. And for instance, an octagon, that was the shit octagon. I misspelled that, but that's okay. That would be 8 minus 2, which is 6 times 180. And I have to use my calculator to do that. 6 times 180. And that one would be 1,080. Lots of size in those angles. Now, you won't use that a lot, but here's where you might use it. All right, so you might see a picture like this in your homework. I'm going to try and draw it as close to what it looked like in your book. And this says this is 32 degrees, and this is 135 degrees. And then it says, what is x? Well, okay, so I'm going to have to draw that again on the next page because I'm going to do some things with it. So let's try it again. This is your teacher not planning ahead, which is pretty typical, don't you think? All right. So this is 32 degrees, and this is 135 degrees. And the question is, what is x? So I would start, if I had this problem, I'd go, well, let's just talk about what I know. If this is 135 degrees and this is 135 degrees, those are called vertical angles. If this is 135 degrees, then this one right here is 180 minus 135 degrees. And so 180 minus 135. And so this one is 45. And if that one's 45, then that one's 45. If this is 32, then this is 32. All right? So now we know that the sum of the interior angles have to add up to 180. So I'm going to take 45 plus 32. And 45 plus 32 is 77. So this angle in here has to be 180 minus the 77, which would be 103. If that's 103, then this is 103. So the measurement of x is 103 degrees. And that's how I get that answer. I can get any other angle in there that I want, but that's basically what they're doing there. All right? So I'm going to do another one so you can see another example of that. I'm going to do a triangle that looks like, or a shape that looks like this. Two parallel lines, and I'm going to do a triangle in the middle of it. It's going to go like that, and this one's going to go like this. And they label this as 59 degrees. They label this as 66 degrees. And then they label the angles 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And so now I can answer questions about any of those angles. The measurement of angle 1, the measurement of angle 2, the measurement of angle 3, put little m's in front of those for measurement, the measurement of angle 4, etc., 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so you might be going, oh my God, where are we going with this? Well, let's start with the things we know. We'll fill in the ones we know first. If this is 59, then 2 also is 59. Okay? Now you might go, that doesn't look like 59 degrees, Mary Beth. We're not going by looks, we're going by what the problem says. If this is 66, then 9 also has to be 66. Okay, now, if this is 66 and that is 59, I'm going to add those together. That is equal to 125, and 180 minus 125 is equal to 55. So this has to be 55. Maybe doesn't look like 55, but it has to be. So 7 is 55. If 7 is 55, then so is, I'm going to let you think about that for a second. That would be angle 12. Would also have to be 55. And then, okay, so now if I know that 7 is 55, then I also know that 8 has to be 180 minus 55, which is 125. So 8 is 125, so 11 is 125. Okay, so now I know that. What else do I know? Okay, let's look at angle 5. Angle 5 is over here. I don't know what that is yet. I do know that's that. Okay, I know what that one is. All right, I do know that these two lines are parallel. So if this is 66 degrees, 4 has to be 66 degrees. Okay, it's called alternate interior angles. Okay, if 7 is 55 degrees, then 5 also has to be 55 degrees. Now, if 5 is 55 degrees, then 1 has to be 55 degrees. If 4 is 59 degrees, then 3 has to be 59 degrees. Sorry, 4 is 66 degrees, then 3 has to be 66 degrees. And I can just go through each of my angles. This is also 66 degrees. And angle 10. Angle 10 has to be the same as angle 6. Wait a minute, I think I've got two things labeled. Angle 9 is 66 degrees. Angle 6 is not 66 degrees. That was a mistake. Angle 6 would have to be 180 minus 66 degrees would be 114 degrees. And so angle 10 would also have to be 114 degrees. And so I can get each of my angles done that way. Okay. Then the other thing that they talk about in this section is what they call congruent shapes. Congruent shapes are two shapes that are the same size and the same angle. Shapes are the same size, same angle. So, for instance, in our classroom, y'all remember what that looks like? It's been a while. All the tables are congruent. I think all the whiteboards are congruent. Okay, so they're same size, same angles, congruent shapes. So if you know the angles of one, then you also automatically know the angles of the other. I'm going to stop there.